Hello everyone, my name is Hubert and welcome to Teach Me channel. Today we will go over GCSE chemistry, acids and bases. Now this is important topic because this will form a good base for your further studies, no pun intended. So, without further ado, let's get started. Now, what are acids and what are bases? Well, acids are molecules and compounds that in water, when dissolved in water, they end up forming hydrogen ions, the H plus ions. Whereas alkali, the bases, are similar in a way that they form ions in water. However, they form hydroxide ions. They form OH minus ions. So this is important because this explains a lot of properties of acids and bases. Now, strong acids and very strong bases are considered to be quite harsh chemicals. And that is due to their ability to form these ions, because these ions are in an ionic form. Therefore, as you know from ionic bonding, these tend to react with stuff. These tend to be quite reactive. So they can also react with your skin. They can also react with your membranes. That's why these strong acid and strong bases are considered, in general, harsh chemicals. For example, at the very acidic end of spectrum, we have, for example, car battery, which obviously is a very harsh chemical. And at the very basic end of spectrum, we have bleach, which again is a very harsh chemical. And that's all down to these ions, the reactivity of these ions. Now, we got this out of the way. We know what acids are, we know what bases are. Now, how do we measure this? How do we measure whether something's acidic, whether something's basic, or whether something's neutral? How on earth do we do this? Well, we measure it using a pH scale. Now, pH number is a number that will tell us how much of H plus ions a molecule has, or how much of OH minus ions we have in water. You know, like if we dissolve a molecule in water and then we measure this, we can measure how much H plus ions there is, how much OH minus ions there is. And that's what essentially the pH number is. That's what pH number tells us. And because it is able to tell us that, it is able to tell us whether something's acidic or whether something's basic, and how acidic or how basic something is. And that's really important. Now, there are two main ways to measure this. There are two main ways we can get that pH number we're looking for. One way is electronic. So we have a device somewhat like this, where we have this stick hooked up to an electronic device, and that stick will measure the electric currents, and this way it will be able to deduce how much H plus ions and how much OH minus ions there are dissolved in water, mixed with the molecule of interest. And therefore it will, on a screen, the pH number will pop up on the screen. Simple as that, and we know what the pH number it is. Now, we can also do this the old school way. We can do it using wide range indicators. One example of wide range indicator is the universal indicator, which is a green liquid like that, and it essentially acts as a dye. If you add it to an acid, it will change color. If you add a base to it, it will change color. And this is what I drew here. The more basic something is, the more purple the universal indicator will turn. The more acidic something is, the more red the universal indicator will turn. Now, let's talk about pH numbers again. pH numbers go from 0 to about 14. Now, this tells us how acidic something is or how basic something is. Number 7 is the neutral number. Number 7 is the neutral number, and pure water, pure distilled water, would be at that number. Now, most of water wouldn't be because it isn't pure, but pure water would be neutral, and it would have pH of 7. And universal indicator in that case would stay green, the way it was. Now, the higher the number, this is important to remember, the higher the number, the more basic something is. And universal indicator will turn more purple. So toothpaste would be somewhere along here, 8 or 9, maybe 10. Pancreatic juice from our pancreas would be between 10 and 11. And then bleach would be around 13, and caustic soda actually would be at 14. So the more basic we go, the more purple we go, and the higher number we get. Now, for the acids, the more acidic we go, the lower the number is. For example, vinegar would be somewhere around the 3 and 4 end. And stomach acid would be around 2. Also, car battery acid would also be at around 2. So the more acidic we go, the lower the number we go, and the more red we go. The more red the universal indicator would become. So that's how we can measure, that's how we can actually quite precisely measure how acidic something is, how basic something is. So knowing that, knowing what acids are, knowing how to measure them, so what? So what else? What do these things do? Well, these things can react. These things can react. And the most common reaction is the neutralization reaction, where you add acid to an alkali to neutralize them, to get rid of them both, because they are essentially opposite ends of spectrum, and that way you can get rid of both of them. So the main formula is that if you add acid to a base, what you will get is water, and you will also get a salt. So I will show you an example. For example, we have hydrochloric acid, HCl, plus common base is sodium hydroxide, NaOH. So what this will make is, this will make us H2O plus salt, which is sodium chloride, NaCl. Now, salt doesn't always mean sodium chloride. It means a soluble compound that contains one metal and one non-metal. So this can be different depending on acid we use. For example, if we say use the nitric acid, that would be different. If we used a sulfuric acid, that could be different as well. Or as same for bases. If you use different bases, if we say use calcium hydroxide, we would have calcium here instead of sodium. But that's the general formula. That's the general formula for neutralizing an acid with a base. Now, how do we arrive at this formula? Why does it happen this way? Well, if we think about it, acids give us H plus ions. Acids will give us a lot of H plus. Now, bases will give us a lot of OH minus ions. So we put down OH minus here. So seeing that we have these ions and H pluses are positively charged, OH minuses are negatively charged, something is bound to happen between them. They will attract each other and they will react with each other. And as you probably worked out already, that's how you get water. two hydrogens and one oxygen. That's how you get water. And then whatever is left over makes that salt for you. So that's how acids react with bases, and that's how we can neutralize them. If we have a way too strong acid, we can add some sodium hydroxide, boom, we neutralized it. And if we have something way too strong base, we can't get to somewhere because it's too basic, we can make it acidic by adding some hydrochloric acid or something. Okay, so this is it for today, guys. I hope this helped you immensely. Thank you very much for watching. If you want to stay up to date on daily science, maths, and biomedical science videos, hit that subscribe button below. Thank you again for watching, and see you next time.